Midas IT Philippines, an innovation company who develops civil, structural, and geotechnical analysis and design software, is launching a podcast for Filipino aspiring and practicing structural and geotechnical engineers. This is Structurally Speaking, a podcast you can listen to while at work.
Welcome to this episode of Structurally Speaking podcast, where we invite Midas user experts to talk about their field of expertise in civil engineering. For today's episode, we will be talking about the fundamental principles of foundation engineering and some advices from one of the most influential geotechnical engineer and structural engineer not only in Davao City, but also in the Philippines. And before I mention his name, let me give you guys some background about him. He finished his Doctor of Engineering in Civil Engineering major in Geotechnical Engineering from Mindanao State University in January 2020. He finished his Masters of Civil Engineering major in Structural Engineering as a grantee of the Graduate Fellow Scholarship and DOST PCIERD Scholarship at the University of the Philippines, Diliman in 1991. He graduated magna cum laude in his bachelor's degree at the University of Immaculate Conception in Davao City in 1986, and he was also a former faculty member in the Engineering and Science Department of the University of the Philippines, Diliman from 1989 to 1991, a former Dean of Engineering program in University of the Immaculate Conception in 1991 to 1993, a former lecturer in the Graduate School of Ateneo de Davao University in 1993 to 1994, and in the University of Mindanao in 1996. He's still actively speaking and sharing his knowledge and experiences in seminars, speakerships, and various occasions. He currently is the owner of 3 engineering firms or companies here in Davao City, specializing in different areas like structural consultancy and construction, manufacturing of pre-engineered steel structures, soil investigation, geotechnical solutions, field and laboratory material testing, manufacturing of innovative concrete products such as patented precast modular blocks for MSC wall construction, and patented precast pre-stressed hollow cores. He is also the founding president and fellow of the Structural Engineers Association of Davao, or SEAD, in 2006, a former president of the Philippine Institute of Civil Engineers, or PICE, in Davao City Chapter 2005, and an accredited specialist in the fields of structural engineering and geotechnical engineering conferred by PICE. Please welcome our guest for today, Engineer Allan Botuyan. Thank you, Doc, for accepting our invitation for this podcast po, no?
Yeah, thank you very much also for inviting me and for giving me this opportunity to discuss more about civil engineering practice here in our country.
Yes, and we all know that you are the expert in this field of geotechnical engineering. And so for all of those who are curious or who are starting or want to know more about geotechnical engineering, how can you introduce geotechnical engineering to them?
Okay. Many civil engineers have little or no idea of what is really geotechnical engineering about. Now, to express it in a very simple layman's term, anything you see above the ground is in the realm of structural engineering, and everything you don't see that is all below the ground supporting the structures is in the realm of geotechnical engineering. So whatever is unseen is in the world of geotechnical engineering. What is seen is in the world of structural engineering. And you put them together, the unseen and the seen.
Yes, and how about, Doc, po dun sa importance po into taking into consideration all the geotechnical aspects of the design, not just the structural aspect, because we all know when we are designing structures, it is planted on the ground, and sometimes it is a misconception to some designers that they assume values for the, let's say, soil bearing capacity. How do you address this kind of issue, these simplifications in the design, and the neglect in the importance of the geotechnical aspect of the design?
Okay. Now, most practice, especially in our country today, we have this what we call presumptive bearing capacities. When you say presumptive, you presume that if the area is predominantly covered by clay or sand, then there is a bearing capacity for that. But the problem is you always base your assumption on what you see above the ground. But the problem is what is below the ground. Let's say 3 meters below, 5 meters below, 6 meters below the ground. That's the problem. And that is why it is very important to conduct proper and precise, accurate geotechnical soil investigation in order to validate those presumptions, because presumptions will only have its limits. And when you presume and then when you validated it and it turns out to be not to your favor, then you're actually causing some dangers to your proposed structure. That's why it's really very important to know where the building or what the building is resting on. Because ultimately, this material, the soil, will ultimately carry whatever structure you build. Whether it's a beautiful structure or not so beautiful structure, the most important thing is it will stand the test of time.
Yes. And given all of that, I think it is quite obvious that we should not take the soil report for granted,
Yes.
or the geotechnical investigation for granted. And as someone who is more focused on the design of structures, say structural engineers, it is sometimes hard to look on the paperwork or the soil report given by the geotechnical engineers. And if you're not yet familiar with this, it's really hard to understand or hard to look at. And what are the parts of the soil report that you really need to pay attention to in order for you to extract the most essential engineering parameters in the soil report?
Okay, so that's a very good question, because many structural engineers or even designing engineers will always determine what happens between the interface between the soil and the foundation.
Yes.
So that's where the question lies. So for example, a very simple building like 2 or 3 story building that will be using shallow type foundation. So the question that first comes into the mind of the designer of the structure is, what is the bearing capacity of that area? Now, where will he get that information? Okay, so the logical answer is the soil investigation report. Now, if he is only to look at the soil investigation report for bearing capacity, that should be the non-negotiable recommendation in the report. There has to be a bearing capacity. And the bearing capacity should not be basically on a value that is constant.
Yes.
Because the soil is generally divided into 2 types, okay? Assuming very, very common soils. So there are what we call the fine-grained soils, or the clay and the silt. Okay, yung mga pino or very, very fine materials that they are densely compacted or loosely compacted. And there is also another type of the soil, which is the coarse-grained soil, which are made of sand, gravel,
The granular types
the
of
granular type. So you have the fine grain and the coarse grain. Now, if it is a fine grain material, if it is a fine grain material, at any level, the bearing capacity will be uniform. So, for example, if it is the bearing capacity is at 2 meters from the ground surface. So, if it is a fine grain material, the bearing capacity is like, for example, 100 kilopascal or 100 kilonewton per square meter. That goes for all sizes of the footing, whether it's a 1 meter footing, 2 meter, 3 meter, 4 meter wide footing. But the difference in a coarse grain material for that level of foundation or for that level of embedment, the footing, the bearing capacity should not be uniform. Because if you remember, for general shear equation like the Tersagi, the Meyerhof, or the Bessick or the Hansen equation, there is this term in the equation that depends on the size of the footing. You will see
Yes.
that B factor there,
Yes, yes.
okay, which is changing, okay? So you change from a smaller foundation size to a bigger foundation size. So as you increase this size,
Yes.
definitely your foundation bearing capacity will also increase. Now, how does it behave? Okay, it will go higher and higher. Okay, it will go higher and higher as you increase the size. But again, at the same time, there is also what we call the settlement factor. Okay, as you increase the foundation size, it will also have this characteristic of increasing settlement. So lumalaki yung settlement as you increase the size. Therefore, as you increase the size, the bearing capacity will also decrease at that level. So for example, if the size of the footing is 1 meter and the bearing capacity for that footing size is 100 kilonewton per square meter or 100 kPa. As it goes to 5 meters, probably it will become 60 or 50 kilonewton per square meter. So for a designer, you have to look at the bore log and then see what type of foundation or what type of soil it is, whether it is fine-grained soil or coarse-grained soil. And when you see if it is a coarse-grained soil, the bearing capacity will not be uniform as the size increases. And it will also change as you go deeper in your foundation embedment depth. But for fine-grained soil, for clay and silts, it's uniform for every level. Basically, those are the things that you would look up to. And another thing, because as a structural engineer, as a designer, you just don't look at the bearing capacity. You will also consider the location, whether the site is prone to liquefaction. Now, what is liquefaction? A liquefaction is a phenomenon where a sandy formation with a shallow water table, when subjected to an earthquake, will liquefy or will behave like a liquid. Okay, so when it liquefies, it becomes very, very soft, and whatever is constructed on it will sink.
Yes.
Okay, that is liquefaction.
Especially during earthquakes.
During earthquakes, because in order to have liquefaction, you have to have three things that should be there instantaneously. One, it should be sand. Second, it should have shallow water table. Three, you have to have a triggering acceleration, which
Like a
is an
triggering
earthquake.
factor. Yeah.
You remove one of these, then you don't have liquefaction. So, for example, if it is not a coarse-grained material, if it is clay, okay, sometimes it liquefies depending on the consistency or the density of the or the stiffness of the clay. Okay, but generally clay materials do not liquefy. So, but for a structural engineer, this should be the things that you have to look for. If it is sandy formation, then look at the report if it is liquefiable. And the next thing is, if it is liquefiable, you have to look for it. You have to look also for the depth of liquefaction. How deep is the liquefiable layer? So most likely, the deepest possible liquefiable layer or the general liquefiable layer is not to exceed about 15 meters from the ground. And of course, we also have to look at the probability of liquefaction. So if there is an earthquake of magnitude of 6 to 7, so this layer would liquefy by how many percent? Like 20%, 50%. So when it is above 50%, okay, geotechnical engineers advise that you have to do some liquefaction remediation methods, such as ground improvements. So if you are the structural engineer, if it is liquefiable, then do not neglect it. You have to consider that in the design. So whether it is avoidance or transferring the load by making the load go deeper by using piles, so that when the soil liquefies, the portion of the pile that will not liquefy will be carrying all the load of the structure.
And now that you mention it, Doc, we've seen the relationship between the different conditions of soil as well as the structure. So we really think that the selection of foundation depends on the types of the soil and the demand from the structure.
Yes.
And from an expert like you, do you have any trade secret or like an initial assessment on the initial type of foundation to be used
Yeah.
in some of your projects?
Okay.
Like what are the let's say trade secrets that you use in selecting the type of foundation?
Engineering knowledge is not really a secret at all. So
Yes.
it's really a matter for engineers to really apply whatever knowledge that you have at the moment and then make it physical in their understanding. What I mean by physical is when you understand what's the nature of the soil in the area, you have to have at least a basic working knowledge of what is underneath. So, for example, if you walk on a shoreline with your girlfriend, kicking some rocks or picking some shells, you will see that for shorelines, it's really an aggregated or a refinement of a mother rock formation that is pulverized. And as you go deeper, the soil or the type of that sand will become bigger and bigger, but that will take a lot of effort to pulverize it. So you will now already know that the sand on the shoreline is normally deep because of its deposition. So when you will design a building, okay, on that shoreline, you already know that a shallow type footing will not work. Okay, it has to be deep.
It has to be
Okay,
deep, like
it
pile
has
foundations.
like pile foundations. Okay,
And
unless of
yeah.
course you want to play with nature and take the
Yeah.
risk. That's okay. If you want your building to float, but nobody will do that in his right mind. So it's not really a secret. Now, for example, if you will be building your house on a slope, a very steep slope, okay, what are the hazards there? So the hazards there is landslide or slope instability. So what are the triggering hazards to cause landslide stability or instability? It is heavy rainfall or a combination of earthquake. Earthquake alone usually don't cause much hazard on slopes. But when it is triggered by heavy
rainfall.
continuous rainfall, so these are the hazards. So as an engineer already, how would you define your type of the foundation? So it will be related to slope stabilization.
Yes.
So you have to create first stabilization intervention before you create the foundation when it is on a slope. Now, another one, if you will be resting on soft grounds, like for example, there is a reclamation of a subdivision where you will create a housing subdivision on a reclaimed rice field. So what will you do? Because you know that it is very soft and the water table is very shallow. So you have to have some intervention that should the building sink, you control the sinking and avoid differential settlements.
Yes.
So what will you do? You enlarge your shallow footing without creating deep type footing. So it's really more of a physical understanding of nature.
Yes. And what I learned during my master's degree is that the differential settlement is one of the most dangerous aspects of settlement in terms of its damage to the structure, because if you have a settlement of uniform, it doesn't affect much the structure, but the differential settlement, it is one of the most critical effects in the structure.
Yeah. Structurally speaking, differential settlement is really very dangerous. Okay, not only the differential settlement, but the tilting,
The
rotating of the structure. Remember the Leaning Tower of Pisa? So it was an engineering failure, but it became a tourist attraction.
It became a landmark.
Yeah, it became a landmark where people would like to take pictures of an engineering failure. Okay, so instead of putting it back to its plumb position, vertical position, they won't. Otherwise, there will be no tourist attraction anymore.
And it also became a monument, like a reminder of the importance of having a good geotechnical report or geotechnical investigation.
Correct.
Right?
And the good thing there is, for example, if the settlement cannot be controlled, at least it has to be uniform, not differential. Okay. If it is differential, okay, you will have unbalanced stresses and your structure will begin to crack or to show some failures already, and you cannot enjoy using it because every now and then, if there's an earthquake, it will have some problems along the way. Okay. Now, if it is just a differential settlement, of course, the only problems there will be your plumbing lines. Okay, they will be a sort of problem, but that's minimal. Your structure is still habitable. Magagamit mo pa rin.
Now, this next question, Doc, this is for the students or someone who is just starting his journey as a civil engineer.
Okay.
And if I were someone with a civil engineering degree and wants to venture or pursue this career in geotechnical engineering, do I really have to specialize or have a specialization like master's degree or doctorate in order for me to qualify in this field? And how about you, Doc? How did you start pursuing this career? Could you tell us something, or could you tell us some background about you?
Now, I may be controversial with the words that I'll be saying, but since this is my own experience, okay, education is not equal to intelligence. Let me say it again. Education is not equal to intelligence. Why do I say that? Okay. Education is the degree or the measurement that you have in the school that you have gained your knowledge. Intelligence is the level of curiosity you have in learning things regardless of where you look for those knowledge. It can be from the formal institution like universities. It can be from seminars.
Yes.
It can be from self-study. It can be from listening to people more mature and more well-seasoned and senior than you are. That is intelligence. So when you are so curious in learning things, whether the condition of a formal education is present or not, then you are an intelligent person. Now apply this. What path to take? Okay. If you believe that you can learn from people inside the academe or the education because you saw a person that you idolize because he has a lot of things to tell you, you have a lot of things to learn from him, then by all means enroll in a university to go to that person. It's not the university itself, but the mentor, the expert, the person you will be taking from that knowledge. But if that person is not present in a formal education context and he is outside, very active in practicing, and you have that way of linking your time with that person to be his disciple, to be his mentee, then go there.
And
So
sometimes it's better to learn from the actual
Correct.
expert who engages in the physical world rather than the...
And this is the problem, and I can speak from experience. When I finished my master's in UP in the 90s, it's not really so much of learning things that are new to me, but it's really more of understanding how to learn and teach yourself. Because your teacher will just tell you, read this book, learn from this, solve this problem. It's more like that. And the effort is 99% yours and not from your teacher. And that's the only thing that sharpened me to learn and how to teach myself to learn new things. But when I get out from the university, I can now focus on the things that I want to learn. Even when I was practicing structural engineering, because as I mentioned, education is not intelligence, but intelligence is curiosity. When you are so curious in learning about things that you don't understand, you begin to experiment. You begin to try new things. Even the theories in the book, you have to understand what are these equations telling us? What are the equivalent physical representation of these equations? Because we are not there to just chew an equation and then apply. It's not like that. Intelligent people wants to understand things. Remember, Einstein proposed E is equal to mc squared. He understood it so well. And other physicists will be amazed. What's that equation about? But without really understanding the physical equivalent of that, that is not intelligence. You're just educated. So, in my experience, when I finish my master's and practice structural engineering, my curiosity, what's happening below the building or below the ground, drove me and made me passionate to learn and to be curious about geotechnical engineering. And because that desire, that intense desire to learn something, to improve myself or to better myself, then I have to practice. We put up the company. We have to diversify. Instead of practicing structural engineering and construction only, we experimented on geotechnical. Then because reading and looking at podcast or YouTube presentation is not enough, then I have to deepen my understanding. That's why I went back to school again.
Yeah.
Not for the sake of the degree, to take my doctorate in geotechnical engineering, but to learn from people. So when I learn from people, then to make the story short, I was able to finish my doctorate. And not only that, I was able to build a network with other experts around the world.
Yes.
And that is intelligence.
Yes, and I think it's best if you really wanted to learn something new or you really sharpen your skills, what you learn from the academe should be applied on the
Correct.
outside world, like solving real problems. Because
Yes.
you in the real world you will encounter problems which is unique, which is very complex. That it is first time that you're solving this problem, and I think it really enhances your problem solving skills, and it really brings out your potential as a professional civil engineer.
Yeah, very good. And as a reinforcement to that, no? If you really want to be impactful in your practice, okay, I've been a teacher for 17 years while practicing. If you really want to become credible with what you are teaching, it is really impossible to have that credibility if
Without
you are
experience.
cocooned
Yeah.
inside a university.
Yes.
What do you mean by that? If you keep on teaching your students inside the classroom and you are not practicing, what you're teaching them is about other experience from the
Yes.
outside.
It's
You
just
don't have
like repeating
credibility.
what's written on the
Yeah, you're just
textbooks.
repeating what is the book,
Yes.
but you don't have a first-hand experience. I'll tell you. If I am the student and then you tell me something about engineering, I'll tell you.
Yeah.
You're a fake teacher. You have to go outside
It's
there.
just like telling what's already written on the book.
Yeah, you have to get out, gain experience, solve real world problems, and
Then
teach us how did you apply these things that you're teaching in strength of materials, in steel design, geotechnical, because you applied it there. Then teach it to us. Then I'll tell you you're a credible teacher.
And as someone who really wants to understand the fundamental principles of geotechnical engineering, it's really sometimes overwhelming at first to read some references because there are a lot of formulas, especially empirical relationships in geotechnical engineering, and it's sometimes overwhelming for a student to read. And for you personally, what are the references or books that you can recommend
Okay.
for a starter or a young students to be able to understand the concepts of geotechnical engineering?
Okay. In any education or in any progression of knowledge, okay, as in a little child, you have to start with the basics. So when you are saying you have to start with the basics, the simplest source of information will always be critical because those are the building blocks of
Yes.
other knowledge. You don't have to start on very complicated things. Go to the basics. And when we're talking about the basics, as much as possible, a book should have this effort to make things as simple as
Yes.
possible. Now, where should we start? You don't have to go to geotechnical engineering first. You have to start understanding basic geology.
Yes.
Okay? And your geology is the study of geo, earth. Okay? Geo, soil. Logi, knowledge. So knowledge. So when you combine these two words, you have to understand it. At least you have to identify. Is this a rock? Is this a soil? Is this an aggregate? Or is this water? You have to understand this first. Next, how do they relate with each other? That's soil mechanics. Okay, from geology to soil mechanics. What are the interaction between the soil, the rock, and water? So that's very soil mechanics. forget about your formulas first. How do they interact in this very, very simple way? And when you have understood that, then you proceed to geotechnical. How does it interact with other structures aside from the soil? So, if I am to recommend, okay, go to the basics, like the book, Geotechnical Engineering and Soil Mechanics Principles.
Okay, we have
So,
we have that book, the Geotechnical Engineering
yeah,
Principles and
By-
Practice
by
by
Kodutu.
Donald P. Kotutu,
Yeah,
Manchurol,
Yeah.
published by Pearson.
yeah. So that is a very good basic. No? Many engineers, especially at this time, are more trained on how to calculate and solve problems when they are given this problem. That is wrong, because calculation is only you want to determine the values. Why? Because you want numbers, but they forget the beginning. What is the philosophy behind solving the problem? Because you may have different results anyway, and that is not any more important. The most important thing is, how do you assess the problem? How do they interact? So that's the more important thing. I remember when I was still teaching in college, when I want to give a problem, I don't want numbers.
Yes.
I tell my students, explain the procedure. Okay, step by step. What will you do? Do not use a calculator.
This is the scenario, and then what you will do.
This is the picture. You just explain to me, because that way I will gauge their depth of understanding, their grasp of the problem. And when they have understood the problem, then I know that they understood the concept. Then I will be using numbers. You know, that's basic. And soil mechanics should be like that, because you are flooded with so many formulas,
Formulas
then
and
they
numbers.
forgot how the formulas were derived by the authors. Yun ang dapat natin maituro.
And actually, we all know that geotechnical engineering is still a growing discipline in terms of research and technology. Could you share us some of the current trends in geotechnical engineering, like the one you're using in your projects, or the one that you used before? And what are some of your most, let's say, challenging projects in the past?
Okay.
And what solution did you use to overcome the problems that you
Okay.
encountered before?
Okay. Now, geotechnical engineering, unlike structural engineering, is really more flexible, okay? More peculiar and unique from place to place. So the geography or the geology of a site is unique from one place to another.
Yes, and we mentioned earlier that when we have the design of the structures, you have a constant FC prime for the concrete, you have
Yeah.
FY for steel,
Yeah.
but in soil, it varies depending on the site location.
Yeah. And also, added to that is, you, the designer, can dictate what strength of steel and
Yeah.
concrete to
Yeah.
use.
Yes.
Conversely, in geotechnical,
You
you
have no
cannot
choice,
dictate.
yeah.
You have to use whatever characteristic of the soil you have on site. Then work around those parameters. So that's the difference. Now, how do we solve a problem? First, you have to have a very strong data gathering attitude. So you don't rely on assumptions. As much as possible, minimize assumptions with whatever technology is available. Now, unlike in concrete, you do not assume. You can mix.
Yes.
When you put a steel reinforcement, you have to specify.
Yes.
FC prime, 60,000 PSI, concrete, 3,000 PSI. That's it. Then use those parameters. Then in geotechnical and in soil mechanics, you cannot choose. Therefore, that's already a problem.
Yes.
Now, to minimize those unknown parameters, you have to gather this problem, or you have to gather this information as accurately as possible. Because in engineering, everything is approximation. So when you approximate things as close to reality as much as possible, then you are actually solving the problem. Now, whatever type of problem, now based on our experience in the past 27 years, so many problems were encountered. Like, for example, if you are constructing a building on an existing landslide. Okay, there is an existing landslide. So we went to the northern part of Mindanao in Cagayan de Oro, and we went to as far as Benguet and Baguio, where there is an ample event of landslides, and you cannot avoid constructing buildings and infrastructures on landslides, like hydropower plants. And how do you do that? So these are really very, very challenging. So what do you do with the data that you get? So you need highly sophisticated software to simulate these things. And we are happy that we are in a generation that we have the software such as the Midas GTS NX. And we are using this in many projects that we find very, very difficult and complex to solve.
Yes, and as of 2023, we have seen this gigantic leap in technology in terms of calculating power, in terms of analysis, and in terms of using advanced software which utilizes 3D finite element analysis. And companies such as yours are now switching to 3D finite element analysis, and other companies also are switching to 3D finite element analysis. And what are your opinions, or how do you assess this kind of switching from 2D to 3D, and what are the importance of using 3D analysis in design?
Okay, so that's a very good question. We are living in a world that is space.
Yes.
Okay, so whether we like it or not, we are 3D, because even in our sitting position, there's a space or there's a distance, and your shape is 3D. Now, when we are trying to solve 3D problems, we are simulating or solving it in a realistic model.
Yes.
When you switch to a 2D, you are making assumptions,
A lot of assumptions.
a lot of assumptions, by removing the 3D reality. So every time you make an assumption, you are getting farther from reality. So as much as possible, we're not saying that 2D is bad, because these are solutions before the 3D. They can solve up to a certain level only. So if your level of confidence on the output of a 2D is this much, okay, because you have, for example, you have 10 variables, and when you put a 2D analysis, you remove the 5. So you're only 50% confident. But when you use a 3D, so you remove only 2 variables. So you are 80% confident, because you have real world or real model representation of problem solving. And of course, if you are solving 3D model, you need a lot of computational power. And that's where sophisticated and advanced software will come in very handy.
And I think 2D analysis is very good in some applications, like you have a soil profile which has a uniform cross sections all throughout. But certain projects demands a more advanced analysis, like the ones that you have, or you will be having the rise of Monterrazas. It has a very complex geometry of the terrain. So how do you relate using 3D analysis in your...
Complex terrains, like the project that we are doing right now, the rise of the Monterrazas of Cebu, it's really very challenging, because its shape is that of a mountain with so many valleys, waterways, creases, mounds left and right, and waterways and cuts and fills like that. So its shape is very complex. Now, when you talk about application of 2D, you are actually the ones dictating where are the locations of the critical slopes. Okay, human as we are limited in our assumptions. We might miss some things because we simplify. For example, if you're saying that the most critical position, or you have an idea that the most critical position of the slope is in the north-south direction, but somehow when you run it in 3D, it will turn out to be 90 degrees of that. And you may miss it. That's why we need software as much as possible or solutions that will create a 3D model, a 3D simulation. While the 2D analysis will also be very effective, then that will just complement the 3D. Because, of course, on the other side, 2D modeling will give you fast results because
The
the
oversimplifications.
information overload is not there.
Yeah.
But for a 3D, you really need a massive hard drive, a massive RAM, and a massive RAM muscle
Yes.
to compute.
Because it's like the simulation of
Yeah,
reality itself.
reality. So you have to balance it out, and it would also be better that you have these two, 2D and 3D, because it doesn't mean to say that you're working on 3D that you don't miss some things also, because in the 2D also there are some detailed work that cannot be found in the 3D, which is the interslice forces. In the 3D, it's all deformation and stress relationship.
So I think that's all of the questions that we need to discuss in this podcast. But I just have one last question.
Sure.
And this is just for our audience that is watching. You can answer like an estimate. So as a geotechnical professional engineer, what is the highest possible earnings that you can get as a professional in this field?
Okay.
Like, just give us a ballpark barley. Is it in thousands, hundreds of thousands, millions?
Okay.
Or
Okay.
you give us some.
Very good question. Now you are migrating into the business world, which I am also very interested to talk
Yes.
about. Okay.
And maybe some of our audience are also interested.
Yeah, so it's really a mindset, no? Now, I don't know if you have read a book by Kiyosaki, Rich Dad Poor Dad series. So there is this book that he wrote about cash flow quadrant. So all of us are earners. Okay? When you talk about earners, whether you're an employee or self-employed, businessman or investor, you have a capacity to earn. Okay, so many people are in the employee zone. Okay, so when they say employee, you work, you get paid with your work. Okay, a self-employed person, or what you call specialist, okay, also is not employed, but he's engaging his services, exchanging his time for money. So, for example, if I am a geotechnical engineer, and then there is a geotechnical engineering company who does soil exploration, then it will be given to him by the company, then he will do a geotechnical report. So that's no different from a structural engineer who has a client, okay, a contractor who will come to him, okay, please design this building. So they're the same. Okay, there is also what we call the businessman. Okay, another quadrant. So the businessman is, the difference is he owns the geotechnical drilling company, he owns the laboratory, and he has a geotechnical engineer. It can be himself, or he can employ other geotechnical engineer. If the person is a self-employed specialist, he will get paid because of his time. But if he is the owner, okay, if he is the owner of the business where he does all the drilling, he does all the laboratory, and then he does also the report. Okay, so there are so many components there. Logically, what we can see is the money that he will be earning is 10 times bigger than when he is doing a report.
That's a lot.
Okay.
That's a lot.
Ayan ah. So, for example, ganito tayo. Put some numbers.
Let's say 50,000.
Okay, sabihin natin report. So, for example, for an ordinary 5-story building, you design structurally. Others will say, okay, the payment is from 50,000 to 100,000. Base lang, ganun. For a geotechnical engineer, okay, for that kind of building, to conduct a soil investigation
Like everything from the investigation to the report.
everything, it's even $500,000. Ano yun? Depending on the complexity of the problem. Like, for example, the more problems you have, if it is liquefiable, if it is prone to landslide, or if it is subjected to a a settlement, a huge settlement. So that's a problem that needs to be solved even before you construct the building. That's why you get paid
Yeah.
more than a structural
So you
engineer.
can really earn your fortune
Yeah.
when you are doing
Yeah.
this.
Okay, so it's really a matter of how far can you cover the service. So for example, if you want to be a structural designer, then of course you'll be paid with your structural design. Same is true with if you are a geotechnical engineer, just to make a report, 1:1 will be the earnings.
But if you cover all the scope of
you
the
cover the scope.
it's like 10 times more.
Yeah, 10 times more because the scope of the geotechnical engineer does not stop with the soil investigation report. You have to design also slope protection, pile design, slope stability, slope stabilization, settlement problems, and a combination of these things.
Yes.
So you have so much leeway there. And if you try to look at the specialist number in the PICE, I don't know how many geotechnical specialists do we have in the Philippines, because last time I checked, when I was conferred specialist in geotechnical engineering, I was only number 33.
Oh, there's so few.
There's so few. Unlike in the structural engineering, PICE specialist, it's more than 200. So
So the demand and
terms
capacity
of
is not
the
balancing
demand
out.
and
Yeah.
supply. Okay, if you are so many in that field, that's what you call red ocean.
Yes.
But if you are so few, you're in the blue ocean. So
So I can see why the geotechnical engineers can demand more because there's
it's
so
not really you can demand more, but the work that you'll be giving is even bigger
it's
than
expansive.
it's very very wide. So that's why when you collect everything, okay, 1:1 ratio there, you have a bigger
So
pay.
it's really possible to earn millions in one
Yeah,
project.
in one project. And not only that, no, it's more of the value added.
Yeah.
Like for example, if you are into structural engineering, if structural engineer A will give this much report value to the building, structural engineer B will also give another report, but not different, two different, the same, or they're almost the same in terms of value. But when a geotechnical engineer will solve a problem, the value added to the project is way, way bigger because you are solving a much complex problem. So the more complex problem you solve, the higher the pay.
Okay. And I think for the students and some young engineers, it's one of the motivational factors from switching to like structural engineering or other regular civil engineering jobs to a specialist geotechnical engineer.
And not only that, no. This is not to say that there is also a guarantee that once you go into geotechnical engineering,
successful.
You'll be successful. No, it's not like that. What I'm trying to say is, if you are very good in your craft, if you are very passionate in your craft, that means you are the best in what you're doing, whether structural, geotechnical, water, transportation, whatever, engineering. Okay? If you are so passionate doing that, you deliver on time,
Yes.
your work is excellent, your customer is satisfied, then fortune gravitates
You'll be
to
rewarded accordingly.
you. You will be rewarded, and your clients will line up before you. Yun yung difference. So it's not really geotechnical, structural. It's really you.
It's really us.
It's really the person. So what the person is made of, if he has that intense desire, if he has that desire to hone himself, to improve himself all the more, even these people, ito mga gumagawa sa atin sa studio, if they excel in these things, then people will be very, very ready to pay them handsomely. Yun yun. And I'm talking from experience.
Yes. And thank you so much po, Doc, for your time and for your knowledge and your sharing of all your
You're most welcome.
experiences.
You're most welcome. And we'll be happy to have some more talks like this for our listeners, for our students who will become future engineer one day. And looking forward that as we grow the community of excellent and better equipped engineers, we will create and contribute a better Philippines.
Yes, thank you so much. And thank you so much for listening to our podcast. And that's all for today's episode. And we hope to see you in our next episodes. And thank you so much for listening. Goodbye.